Hello, Professor. Today we're embarking on a fascinating journey through the world of electromagnetism. This subject isn't just a collection of mathematical formulas and physical laws. It's a path to understanding the mysteries of the universe. Electromagnetism, from its fundamental concepts to its applications in modern technology, has profoundly transformed human life. We'll explore the power of electromagnetic fields and see how they're applied in various aspects of daily life. Professor, let's dive into the fascinating history of electromagnetism. It all began with the ancient Greeks, who made the groundbreaking discovery of static electricity simply by rubbing amber. Imagine their surprise when they realized that a little friction could make objects attract each other. It must have seemed like magic. Then we jump to the 19th century and meet the legendary Michael Faraday. Faraday didn't just observe electromagnetic phenomena, he introduced the concept of the electromagnetic field. This was revolutionary. He showed us that electricity and magnetism are connected in ways we couldn't have imagined before, kind of like science's first power couple. Finally, we arrive at James Clerk Maxwell. These equations transformed electromagnetism from a collection of scattered observations into a structured field of study. It's like he took all the pieces and built a masterpiece. Alright, Professor, now let's talk about electric fields. Electric fields are created by electric charges and varying magnetic fields, almost like an invisible force field that pushes or pulls other charges around it. Imagine each electric charge with its own force bubble, creating influence over everything nearby. The strength of this field is measured in newtons per coulomb, NC, showing just how powerful that force bubble is. It's a bit like measuring the strength of a handshake. Some fields are gentle, while others could really pack a punch. And then there's direction. Electric fields always point away from positive charges and towards negative charges, kind of like social magnets. Positive charges repel, and negative charges attract, guiding the field along its path. Professor, now let's talk about magnetic fields. These fields are created when electric charges move, like an invisible force field that appears as soon as charges start flowing. Magnetic field lines form closed loops with no beginning or end. They just keep going around in circles. And then there's the right-hand rule: point your thumb in the direction of the current, and your fingers will curl in the direction of the magnetic field. It's a simple trick to remember the field's direction. Gauss's law, electric. This law shows how electric fields are created by electric charges relating the field to the charges distribution. Gauss's law, magnetic. This law tells us that magnetic monopoles don't exist. Magnetic field lines always form loops. Faraday's law. This describes electromagnetic induction, explaining how a changing magnetic field can create an electric field. Ampere-Maxwell law. This links magnetic fields to electric currents and changing electric fields. Now, Professor, let's explore electromagnetic waves. These waves are created by accelerating charges, which sets off oscillating electric and magnetic fields. These fields move perpendicular to each other, creating a wave that can travel through space. And here's the amazing part. These waves move at the speed of light when in a vacuum. So every time you see light, listen to the radio, or use Wi-Fi, you're benefiting from the speed and power of electromagnetic waves. Energy generation. Power plants generate electricity using electromagnetic induction. Medical imaging (MRI) scans use strong magnetic fields for detailed body images. Consumer electronics devices like smartphones and computers rely on electromagnetic components. Quantum communication, using quantum entanglement for secure data transfer. Imagine messages that are practically unbreakable. Wireless charging, efficiently transferring power without cords, making it even easier to charge devices. Electromagnetic propulsion. Envision advanced space travel powered by electromagnetic fields. potentially taking us to new frontiers in the universe. As the saying goes, the sky's the limit. With electromagnetism, we're not just reaching for the sky, we're pushing boundaries into the cosmos and beyond. Here's to a future where electromagnetism continues to power our world, inspire innovation, and drive humanity towards incredible new horizons. Thank you, Professor.